Hello. So let's continue. So we can technically also use a magnet to separate things lah. This one is like say primary 5, primary 6 science. But we can only use it on iron, steel, nickel, cobalt. This one really not very significant. It's just something that like that lor. Yep, just now we talked about this, crystallization and everything. So let's say if a solution basically something dissolved in water. So we can actually, solute means the something lah, basically. Solvent tend to be water. So if you want to get the water, you can use your simple distillation. So what's simple distillation? Well, it's very simple lah, that's why they call it simple distillation. Yeah, so the common example is your water, seawater, your NaCl, sugar solution. These are common examples. So let's go into the details. So actually this diagram shows everything. So yeah, as you can see here. Yeah, the thermometer, so basically you will heat, then when at 100 degrees, water will boil. So water will boil, 100 degrees. Water boil, become gas. Then it goes in. Then there's this condenser thing, which is cold water. So it cools down. So here is gas. Then inside here become liquid. It cool down. Once it cool down, it will just flow down. Bloop, 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 bloop. And that's how you collect the thing. Oh, cool. Yep, so that's basically how condensation works. How distillation works. Yep. So you notice all the boxes in green, those are tiny things. It's like the question, part A, part B, then there's always the part C, part D, part E, 1 mark segment. They ask you, why must do this? Why must do that? Those are the things. Why must we add boiling chips? Or to ensure that smooth boiling, it boils properly. Or why must I have a condenser to help it cool? Why use a conical flask? Don't use a beaker. Or smaller surface area. It doesn't evaporate so quickly. These are extra things they like to test, the 1 marks. As you can see, it's like that. It will rise. It's pretty readable. So you take a look. Yeah, so simple distillation is pretty simple. But with any simple thing, there's definitely a difficult version. And there is a difficult version. We call it fractional distillation. Yee. Maths come into play. No, I'm kidding. There's no maths here. It's just called fractional distillation. And we will go on to that soon. Yes, so next one will be your fractional distillation. That will come later. Separating funnel is something quite simple. It's just used to separate immiscible liquid. And what's immiscible? Immiscible means do not mix with each other. So your oil and water, they are considered immiscible liquid. So technically you pour inside this separating funnel, you'll slowly go into 2 nice layers. You turn on the tap. You pour it in. You turn on the tap. One of the layer will go down. Once you finish collecting the layer, you close the tap. Then you repeat for the other one. There is a real life method. They call it decanting. Means you literally just pour lor. We do that in real life, but there is apparently a chemical method. Slightly more efficient. Here we go, fractional distillation. Fractional distillation is to separate miscible liquids Yeah, so these are 3 standard examples here. I would recommend use these 3 standard examples if they ask you for examples. Yeah. So the difference is there is this extra thing here. This extra thing here is called a fractionating column. Spelling very important. We can actually ask you to label. You write down fraction column wrong. Fiction wrong. Fiction also wrong. It must be fractionating. Cannot even be fictional, fractional, no. So what's this column supposed to be? It merely just consists of glass beads. So it gives it an extra surface area for the vapor to condense. To make sure that whatever gas that go into the condenser is the real thing. Yeah. So that's the only main difference in the setup. So this is the what happens. So when it's a water and ethanol mixture, both ethanol and water will become gas, but only ethanol is actually boiling. Water is fake one. Water is called evaporate. So water will condense. So let me help you. Water at 7. So let's say this is 78 degrees. Water not supposed to boil, but it can evaporate. So water evaporate. So because evaporation takes place at any temperature, so evaporate. So it will try to go up. But because of this surface area, it will go down. So it is a gas. But it hits here, it will condense and it will go down. So it's like fake one lah. But if your ethanol will boil. Because boiling point is 78 degrees. So ethanol goes up, goes in, and actually undergo the distillation process. Yeah. So your G, and eventually you get a liquid. So once it's 79 degrees, it means that all the ethanol is out already. Then you can repeat lah. When it goes up to 100 degrees, you do it again for water lor. So I even have like 10 liquid mixed together. It's okay. So very there's a pattern going on here. As you can read. Guys, stay safe, man. You see mosquito, kill the mosquito. Mosquito is no fun. Yep, this can show what happens lah. So temperature rise, but when ethanol is boiling, temperature is fixed. Because recall, during boiling, temperature don't rise because all the energy is used to overcome your forces. So your temperature will literally remain at 78 for a while. But once your temperature start to rise again, that tells me all the ethanol gone now. So the graph is pretty informational. Alright. Okay. So these are some of the common industrial applications in your syllabus at the very least. Chromatography. Okay, so I can tell you in the exam context, the two kinds of open-ended question very long, like 10 marks, 6 marks. The common one they like to test is simple, the distillation and chromatography. And I really hope they test chromatography because chromatography is damn standard, damn easy. So let's see. Okay, so they must be soluble in the same solvent. They must be soluble in, let's say, water. Then you can separate them. It is a must. Without this condition, forget about chromatography. Must. So that paper that the thing move around in, we done it before. That thing is called a chromatogram. You have done this before lah. Yeah, your what spot underneath the line lah, then the what water go up. We done it in the lab with that test tube thing, that boiling tube. So this is the key idea behind it. The more soluble thing will travel faster and further up the paper. So the key word here is further up the paper. Don't even tell me, oh, it travel further. Further where? Further in life? No. So technically it's travel further up the paper. So I have to emphasize on this because students further up the paper. Don't just further. Yep. So in this case, this food coloring is not pure because pure means only one thing one. In this case, pure because two things. The green is made out of yellow and blue. Not pure. Cool. Yep. That's how you read in the chromatogram. Okay, now you learn how to calculate RF value. So basically RF value so let's say in this case let's say this is X cm, let's say this is Y cm. So RF is basically the distance. So this one you need to copy down. This is actually the only calculation you need in this chromatography. Distance traveled by your component, or you may not know it. It has the spot over the solvent front. Solvent front means the distance traveled by the solvent So in terms of number, it is actually just X over Y in this case. Yep. So that's how you figure out your RF value. Yay. So note down this. It is a ratio. Ratio means no units, right? And also RF value is always lesser than 1, greater than 0. It's a ratio Yeah. So we have an unknown sample X here. So we have A, B, C, D. So just by comparing, it seems like the sample X contains the drug C, because drug C is green dot, red dot. X contains the exact identical green dot and red dot. You must contain both, then can say that it is. So that's why you got X got C, but X don't have B. Because why? You look at B, B got 2 dot, B got orange. The orange dot of B matches the orange dot of X, but the blue dot of B don't match. So no. So in order to say that X contains B, you must have both the orange and blue. That's how you read the thing. Okay, this you don't notice the star here because it's standard. Those one of those parts that they love to ask. Name the thing that we add. Explain why we need to add a locating agent. Like logic will tell you, to locate something lah. The locate what? So it it is actually, so you need to write down exactly in that box here. That is a 1 mark guarantee. So it react with the colorless substance to form colored spots. Don't tell me it make it color, give color, dye. No, cannot. It react, it's a reaction. React with the colorless to become colored. Cool. There are many uses lah. You can use to separate, you can use to identify, determine purity. Yep. Then the very last part of this is your purity of substance. It's important for chemicals to be pure lah. Because you don't know what dirty things inside. Sekali got some poison inside there, then you eat, then you die. You know. So there are a few things we can do. Technically, there are 2 things. Number 1 and number 2. I will tell you that this is preferred. What does it mean? So a pure solid have a fixed melting point. Pure liquid has a fixed boiling point. Means impurity decrease the melting point, blah 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 blah, increases the melting point. Yeah, but this diagram basically summarizes it for you. So we use water as an example, okay? So we know water melt at 0 degrees and it boil at 100 degrees. So basically this is the pure. So what happens if there's impurity? In my word, I would say impurity stretches things. So it will now melt over a longer. So it will now melt from 0 to 4 degrees. It will melt over 4 degrees. Melt over lower temperature also. And it will also boil from 100 to 104 degrees. So you notice there are 2 main differences. It no longer melt and boil at one particular point. It is over a range of temperature. And second, it is no longer at exactly the boiling point. It is the boiling point and higher. The melting point and lower. So it stretches things out in that sense lah. So that's what impurity do. Alright. Yep. That's about it. So let's move on to the very last element compound mixture, which is very thin, very simple. What is an element? Seriously. Okay, don't worry, we won't test you on the definition of element. Element is basically the simplest form. Now these are the symbols of elements. We know that. Atom. Atom, I always like to say atom means 1. 1. So, and molecule means more than 1. Means all these here are considered atom because it's Ca, C, H, Fe. They are one thing, literally one only. Whereas molecule are things that are more than one lah, like CO2, C6H12O6, NaCl, MgCO3. So in terms of atom molecule, it's literally just I got one or more than one. Nothing to do with bonding. Polyatomic. Well, the word poly means more. More than atom means more than one lah. It's not a big deal. Compounds are chemically bonded. They have fixed ratio. Yeah. So these are some examples. Formula wise not an issue. We already done in the topic of formula. Mixture are just physically mixed. They are not chemical reaction, just physically mixed. No fixed ratio. Or for example your Milo. Oh, today I feel like drinking more concentrated. I add more powder lor. So a Milo solution is like a mixture. You happy, you add more. It's fine. Yep. So this is the main thing here. So compound mixture main differences mixture can be separated using physical processes. You can filter lah, magnet lah. But compound must use chemical. Means you need to use heat this is heat. You need to use electricity. It's not so easily broken down anymore. So the chemical property of mixture is the same. If you take sodium chloride and sand mix together, we still sodium chloride property and sand property what? Because they don't react, it's just anyhow mix only. But for compound, the new compound will be a different mixture. Okay? Okay, next. Yep. No chemical reaction, got chemical reaction. So this is are always in fixed proportion. In random. Means you happy you want more Milo lor, you know. Yeah. See, that's about it. That's the main thing. That's about it. We are done with the whole syllabus for your end of your exam. Yay!